Question D. The bulb of a pendulum is given a positive charge and oscillates with a small amplitude above a large earthed metal plate. Explain how the period differs from the case where the metal plate is absent. So, two cases. You've got pendulum bob that's charged, oscillating back and forth, and it is above a large earthed metal plate. The other case, pendulum still positively charged, but this time it is not above a metal plate. So we're trying to compare the two and explain how the period differs from this case. So in this case there is just a normal pendulum action going on. The charge is not interacting with anything. So we'll just say the period equals t. In the second case here, you can think of a large metal plate that's connected to ground, earthed metal plate, that is what it says. So you can assume that is a source of electrons. So lots of electrons can be in there. Now, as it swings back and forth, you're going to draw up into the surface of this large earth metal plate a whole bunch of electrons, because the positive charge will attract them. What this will do is introduce force of attraction, electrostatic force, down towards the charged plate. We'll call it Fe for electrostatic force. So we have this extra force on top of the force due to gravity, which is attracting it down. That's going to have the effect of increasing the restoring force. Okay, so there's a force which brings the pendulum back towards the equilibrium. In simple harmonic motion, it's proportional to the displacement from the equilibrium. But just for a general pendulum, the further away you get, the greater the force is going to be to try and bring it back towards the equilibrium position. Not necessarily direct proportional, but only in that small angle will it be direct proportional. Either way, it's increasing the restoring force, which means the acceleration towards the centre will increase, meaning the period should decrease also. You would say that there might be further effects, but that's probably the main thing that we're looking at, is that the period will decrease for the charged metal plate because of that extra force. As the closeness that force is going to be maximum at equilibrium position, so you might say it's also going to have a damping effect, which is maximum the closest you get to the equilibrium. So it's going to be harder to move. Like, for example, if you have the plate out here, because this electric field from the charge is radial and it's decreasing, so the further away you are, it's an inverse square relationship for the electric field. That means the force is going to be less the further up it goes. That means, as I say, greater force in the centre, which means it's going to be harder for it to move, for this pendulum bob to move away from the centre. So as it stretches out here, it's going to be that initial point, it's not going to want to move on. So the tendency is to have a force that keeps it in the centre. That means that damping will be quite strong at the centre compared to the rest. So you'll have effected a stronger damping for the simple harmonic motion if it is undergoing simple harmonic motion. Otherwise you just would consider that the period is decreasing.